Hey friends, so now what we're going to do in lesson 3 is we're going to take a look at derivatives of logarithmic functions. And we're actually going to use what we did yesterday with derivatives of exponential functions. Those are things we now know. So we're going to use those to figure out some common derivatives for logs. Okay, so yesterday's discoveries were the following. We figured out that the derivative of e to the x is e to the x, and the derivative of b to the x is b to the x ln b. Okay, so we're going to use those to develop a couple for logs. So using these facts, let's determine the derivatives of y equals ln x and y equals log base b of x. In your final answer, there shouldn't be any y terms, and I'll show you how we handle that in a sec. So hint, turn the following into something that you do know how to take the derivative of. So the first one we're going to take a look at is y equals ln x. Well, I don't know anything about that right now, but I do know that ln x is log base e. So I'm log base e of x, right? So I'm going to convert that to exponential form. Base becomes the base, the guy that was locked becomes free, the guy that was free becomes locked. You'd be very comfortable to say that that's e to the y equals x. Okay, well, let's take the derivative of that. I know that the derivative of e to the y would be e to the y times the derivative of the inside function. The inside function there is y, so that would be derivative of y. And then I know the derivative of x is 1. So I'm looking at e to the y derivative of y equals 1. So now if I want the derivative of y by itself, I'd want to divide both sides by e to the y. And that would give me the derivative of y equals 1 over e to the y. Okay, but we said we wanted to set this up so that I did not have any y's. So what does e to the y equal? Well, e to the y equals x. So we just discovered that the derivative of ln x is 1 over x. Okay, the derivative of ln x is 1 over x. Okay, that's the first one we want to discover. The second one, and we're going to do a very similar thing, is we want to look at y equals log base b of x. So let's convert that to exponential form. That'll be b to the y equals x. And then I'm going to go ahead and take the derivative of that. The derivative of b to the y would be b to the y times ln of b times the derivative of y. And then the derivative of x is 1. Okay, so now, again, I'm trying to get d to the y over dx, or dy over dx by itself. So I'll divide both sides by b to the y ln b. Okay, but also, again, I don't want to write anything in terms of y. So what I'm going to do is I'm going to say, hey, b to the y is the same as x. So now that becomes 1 over x ln b. Okay, so essentially, the derivative of ln x is 1 over x, and the derivative of log base b of x would be 1 over x ln b. Okay? Okay, so here is a summary of where we are so far. This purple guy here that I might be in the way of, I'll just hide myself for a second. That purple guy is one we discussed yesterday with exponential. Okay. If y equals b to the f of x, then the derivative will be b to the f of x times ln b times the derivative of the inside function. Okay. Likewise, I'm going to head over to here for a second. If y equals ln f of x, then I'm looking at 1 over f of x, again, times the derivative of the inside function. And then for log base b of f of x down here, I'd be looking at 1 over f of x ln b times the derivative of the inside function. Okay, so what we want to do is just practice using some of these derivatives. So we're going to start with y equals ln of 2x cubed. Well, we said that the derivative of ln x is 1 over x. So the derivative of ln 2x cubed is 1 over 2x cubed. But then I have to multiply it by the derivative of the inside function. The inside function here is 2x cubed. So the derivative of 2x cubed would be 6x squared. Okay, now I just want to clean this up. That 6x squared can go on the top. 6 over 2 is 3. And x squared over x cubed, I'd have an x on the bottom. So simplified version would be the derivative of y is 3 over x. Okay, that's the sort of stuff we're going to do today. Easy peasy. Okay, y equals ln x times x squared. So I need you to see the product rule here. So we're going to go through this step by step. Derivative of f. So ln x, the derivative of ln x is 1 over x times g, so times x squared, plus f, which is ln x, times the derivative of g, which would be 2x. Okay, so I just got to get my mouse working again. So I've got 1 over x times x squared plus ln x times 2x. Okay, now I want to clean that up. X squared over x is just going to give me x. So that's going to give me x plus 2x ln x. And then I can factor out an x. So that'll leave me with x times 1 plus 2 ln x. Okay. Awesome. Okay, let's try the next guy. Y equals ln tan x over x. So we're going to throw a little trig in here. And we've got the quotient rule. Okay, so the quotient rule is derivative of f times g minus f times derivative of g over x squared. Okay, so the derivative of f, well, the derivative of ln tan x would be 1 over tan x times the derivative of the inside function. The inside function is tan x. The derivative of tan x is secant squared x. Okay, so that's going to give me 1 over tan x times secant squared x times g, which is just x, minus f, which is ln tan x, times the derivative of g, which is just 1, all over g squared, which is x squared. So this is where we are. I've got 1 over tan x times secant squared x times x, that was my g, minus f times the derivative of g over g squared. Okay, now in order to clean this up, take a look at this for a second. Essentially, I want that as one fraction. So I'm going to need to multiply this guy by tan x over tan x. Wow, I'm doing a bad job of writing that. Tan x over tan x. Okay, that way the whole top is over tan x. And if the whole top is over tan x, that tan x can come down and become part of the denominator. Okay, but what that means is the second term, the term on the right there, is going to end up being minus tan x ln tan x. Okay, and so my simplified version, just let me get rid of this ink for you. The simplified version of that is secant squared x times x minus tan x ln tan x all over x squared tan x. Okay. Now that I'm happy with as far as simplification, I don't need you to take it any further than that. Okay. If you did want to try and take it further, you can. As long as you do it right. But this is, I'm happy with where we are right here. Okay. All right. Y equals 3x to the 5. Well, really, I could have asked you this one yesterday. This is just b to the x, right? So the derivative of y equals 3x to the 5 would be 3x to the 5 times ln 3 times the derivative of the inside function, which is x to the 5. The derivative of x to the 5 would be 5x to the 4. Okay. Awesome. Okay. Y equals 4 log base 2 of the root of x. Okay, so we've got log base 2 of the root of x. So the derivative of log base 2 of the root of x would be 1 over root of x ln 2. Okay, then I have to take the derivative of the inside function. The inside function is root of x, which is x to the 1/2. The derivative of that would be 1/2 x to the negative 1/2. Okay, so this is where we are so far. Now I've got 4/2, so that's going to just be a 2 on the top. And then this guy is root x on the bottom. So on the bottom, I end up with root x times root x, which is just going to be x. So cleaned up version will be 2 over x ln 2. Okay, 2 over x ln 2. Okay. All right, now let's try this guy. Y squared equals ln of x cubed minus y. So we're going to do this implicitly. We're going to take the derivative of both sides. So let's talk on the left first. The derivative of y squared would be 2y derivative of y. The derivative of ln x cubed minus y would be 1 over x cubed minus y. Then I have to take the derivative of the inside function. So x cubed minus y, the derivative of that would be 3x squared minus the derivative of y. Okay, so I've got 2y derivative of y equals 1 over x cubed minus y times 3x squared minus derivative of y. Now, big picture item, we're trying to get derivative of y all by itself. What I'm going to do is I'm going to multiply both sides by x cubed minus y first. That will get rid of my fraction there. So I end up with x cubed minus y being multiplied on the left, and on the right, I'm left with 3x squared minus derivative of y. So now I'll add derivative of y to both sides so that I have all the terms involving derivative of y on the left. Okay, now I can factor out dy over dx because both of these terms have derivative of y. So I'm going to go ahead and factor that out. My big old head might be in the way for that guy. I'm going to hide myself for a sec. So I end up with derivative of y times 2y times x cubed minus y, and then plus 1 equals 3x squared. Now, essentially, if I want derivative of y by itself, I have to divide both sides by this. So I'm going to do that, but at the same time, I'm also going to distribute this because that's not in a fully factored form because of that plus 1 on the other side. So I really just want to get rid of the brackets to clean that up. So that's going to be 2x cubed y minus 2y squared plus 1. Okay, I'm just going to bring myself back there. And when I do that, that's what I get. So the derivative of y is 3x squared all over 2x cubed y minus 2y squared plus 1. That's a fun one, hey? All right, so this is now where I'll leave you. You've got some homework to practice there. And then in our next lesson, now that we've talked about some derivatives, we're going to take this to the next step, which would be curve sketching of exponential and logarithmic functions. Okay, so I will see you there. Have fun with your homework and connect with me if you do have any questions. Okay, take care, guys.